Welcome to Amplify Academics. This video we're gonna be discussing about the properties of log. I've already made a detailed video on log and its properties, so you can go and check that out. But over here we'll be just discussing about the log properties or the formulas. So let's see the first property. Property 1. Let's say you have log base b and the argument is also b. So over here the argument and the base, they're both equal, which will result in 1 as the final answer. So let's see an example. Log base 5 and the argument is also 5. So the answer to this is 1. Next property. Let's say you have log base b and the argument is a. And if you want to flip or switch the positions of base and the argument, then you can directly write it as 1 over log base a, argument as b. Example, log base 5, argument 2. So it's 1 over log base 2 and argument as 5. Property 3. Let's say you have log base b and argument as a. You can also rewrite this as log base 10, argument a, log base 10, argument b. You can also choose not to write base 10 because if you don't write the base, then it's by default log base 10. So this is basically it. Let's see an example for this. Let's say log base 5, argument 2, log base 10, argument 2, and log base 10, argument 5. The fourth property, log base b, argument a, and let's say we have an exponent or the power on a, which is the argument. We can bring this m, the power, in front of log and put it there, and rewrite this as m log base b a. You can also do the reverse thing. You can also take the m and put it back on the argument as the power, so you can do that as well. Example, log base 5, argument 4, rewrite this as 2 square and base 5. Bring this 2, put it here. Final answer is 2 log base 5, argument 2. Next property. Let's say you have, this time you have the exponent or the power on the base. So b to the power n, let's say, argument a. So we have a 1 here, in the invisible 1. You can drag this power and put it underneath that 1 as the denominator. And rewrite this as 1 over n log base b, argument a. Example, log base 4, argument 3, log base 2 square, argument 3. Grab this here and put it there. It's going to be 1 over 2 log base 2, argument 3. Next property. Sixth, log base, let's say b, and argument a. And let's say, just like the previous property over here, we had the fourth one, we had m on the argument a, and we had n on the base b. This time, let's have the exponent or the powers on both of them. Let's say m and n. So you can grab m or the power, both of them, and put it here in front of log and rewrite this as m over n log base b argument a. Example, let's say log base 25, argument is 27. Rewrite this as log 3 cube 5 square, and we have 3 over 2 log base 5 argument 3. Next property 7. So next property we have, let's say, log base b, and we have an argument which is 1. Let's say, now base can be anything, argument is 1, so the direct answer is 0. So I'm going to give you the explanation for this, but let's see an example first. Let's say log base 5 and the argument is 1, answer is 0. So the explanation behind this is we're going to use the property 4, which is when you have an argument when you have a power on the argument and you bring it in front of log. So we're going to use this property. Let's say log base 5 and the argument is 1. We can rewrite this argument as log base 5 and let's say 2 to the power 0. Again, you don't have to specifically select 2. You can just select randomly any number, or you can also put a variable, because anything to the power 0 is 1. So I just randomly selected a number. So when you bring this 0 in front of log, you have 0 times log base 5, 2. So 0 times the log term is 0. Hence, the answer is 0. So that's how this property works. Number 8. Let's say you have a constant number, b, and you want to rewrite, or basically you want to put a log term on top of this constant number b. And the base that this log term has is the same as this base, which is b, let's say. So what we can do, and let's say the argument is a, so what we can do in this property is whenever you have the log term having the same base as the base of this log term, then this entire thing cancels out, or entire thing goes away, and you have the argument left. So that's the answer. Example, log, oops, my bad. So let's say 5 to the power log base 5, and the argument is 2. So this entire thing goes away, and the answer is 2. We can also see another example for this. Let's say you have e to the power ln 2. Now in this case, ln has a base of e, means because ln is basically, you can consider as log base e. So since this ln term is log base e and the base are same, so this entire thing goes away and you have 2 in the end. So that's how it works. Now the 9th property, which is, let's say when you have multiple log terms, log base b argument a plus log base b argument is c. So when you have multiple log terms and they're added together with the same base, what you do is you multiply their arguments, log base b a times c. So the factors are addition, same base, and multiply arguments. That's how it works. Now, in case if you're wondering what happens when we have same bases, or different bases, my bad. So if you have different bases, let's say log base C and argument A plus log base B and argument is D. In this case, nothing's going to happen, no operation. It's because your bases have to be same in order to either multiply or do any sort of operation. So in this case, your bases are different. Doesn't matter if your arguments are same or not. So if your bases are different, nothing's going to happen. So we can see some examples. So let's say log base 5, argument 2, plus log base 5, argument is 3. In this case, bases are same, so the arguments you're going to multiply, and you'll have log base 5, argument is 6. So that's the answer. And if you have different base, let's say log base 5, argument is 3, plus log base 3, and argument is 2. Nothing's going to happen because their bases are different. So different bases, no operation. So nothing's gonna happen. So yeah, next property is number 10. It's a similar thing, but again, when you have multiple log terms, let's say log base B, argument A, and there's subtraction or minus log base C, sorry, same base, so log base B and argument as, let's say, C. In this case, when you have same base and you're subtracting the two log terms or multiple log terms, you're gonna have to divide the arguments. So A over C, and the base is B. So it's the same thing again, just like the previous property, where your bases have to be same in order to carry out any sort of operation. So if your base is different, let's say if you have log base B, argument as A minus log base, let's say C, and argument as D. So nothing's gonna happen. So again, factor, same base, minus, you divide arguments. But, however, on the other hand, different base, no operation. Nothing's gonna happen. Let's see some examples. Let's say if you have log base 5, argument is 2, minus log base 5, argument is 3. So what's gonna happen is you're gonna divide the arguments. And if you have log base 5, argument is 3, minus log base, let's say 4, and argument is 2, nothing's gonna happen. So you can definitely simplify this, but your arguments won't have any operation. So I actually change for better understanding, I actually change the argument. So let's say log base 4, and you have, let's say, 7. So no operation will be done on this specifically because their bases are different. So yeah, these are the properties of logarithm, and I hope you enjoyed this video. And please, if you enjoyed this video, then do subscribe our channel. And yeah, I'm going to see you again in the next video.